Okay, I picked up one of these welders recently at a good price. Most of the time I've had a Lincoln Square Wave welder for TIG welding, but I decided I'd finally make the investment and get a wire welder. They're so much easier to use for just slapping steel structures together. So I have to say I really like this welder. It does a good job for just about any sort of steel work I'd want to do. And if you don't want to get too involved in knowing the details, under the lid here, it's got a pretty good assortment of settings for thickness of steel and type of wire and so forth. So that'll pretty much get you going regardless of any details that you don't want to know about. But one of the things that I was sort of curious about is the controls here. For example, the wire speed goes from a turtle to a rabbit. So I don't know what that means in inches per minute. And then the voltage, it's got letters here, A, B, C, D, E, which each one represents a different range of voltage, but I don't really know what the numbers were for this. And if you're trying to compare this with, say, some other recommended setting for a wire where they give you the actual volts and the wire speed in inches per minute, it leaves a lot to be desired. So I took the opportunity to put some instrumentation on this welder, and I measured the actual wire speed, timed it, I think it was for 5 seconds, and just measured the length of wire that came through there. And I've got a nice graph that shows you that. And then in terms of the voltage setting here, these are relatively simple welders. These things basically control the tap settings on a transformer, so it doesn't give you a specific voltage, but each letter gives you a range of voltage. And the exact voltage that you get has a lot to do with what wire speed you've set on here. So I added some instrumentation where I measured the actual welding current and the actual arc voltage, taking like 100 samples per second. And I'm going to show those to you in some graphs. So I think these might be pretty useful to a lot of you. And feel free to send me any comments you might have. So here's some of the other graphs that I have here. Okay, now to measure the arc voltage, I just connected up my measuring equipment across these two leads here, and you'll get the measurement. I had a 10 kilo ohm pot across there, and then I adjusted it to get a voltage that would be compatible with my measuring device. And then for measuring the current, I have this 300 amp shunt resistor. So you see I got the ground clamp on that, and at 300 amps this puts out 50 millivolts. So I need to run that signal through a little amplifier circuit, and then I sent that out to my DATAC computer data acquisition board. And I was measuring at 100 samples per second and 120 samples per second. All the circuitry seemed to work just fine. Okay, one of the first things I wanted to do on this welder was measure the actual wire feed speed. The dial settings on the machine take you from the speed of a turtle to the speed of a rabbit, and I don't know how many inches per minute that is. So I did some actual test measurements, ran the wire for I think 4 seconds, and measured the length that came out each time for each number on the dial of the machine. And so this is the graph that I got. Here's the machine setting 1 through 10, and this is the actual wire speed that I measured and converted that to inches per minute. So what I got here is this blue line. So for setting number 1, it's about 30 inches per minute. Number 10, we're up about 480 some inches per minute. And these are the numbers I got for each of the speed settings on the machine. So it's looks amazingly linear in terms of the dial setting versus the speed coming off, and that you might think that's a pretty good thing. But one thing I want to point out here is when you're up at the high settings like 10 and you go down to from 10 to 9, you've decreased the wire speed about 10%. Here again, 9 to 8, about 10%. But when you get to these lower numbers, there's a much bigger difference in the wire speed for each number setting on the dial. For example, if you go from a speed setting of 3 to 2, you've just dropped the speed from 140 inches per minute down to about 80 inches per minute. So that's a pretty big change in the wire speed, and the amount of change that you get, actually I've plotted on this purple line and use the numbers on this axis. So if you go from a 3 speed to a 2, the amount of change you've gotten would be this number right here, which is 40%. So that's a pretty big decrease in wire speed, just going from 3 to 2. If you go from 2 to 1, you're going to go from over 80 inches per minute to less than 40. So what that gives you is this number right here, which is actually a 60% decrease in the wire speed. So you need to bear that in mind when you're making adjustments on the machine. If you're in the low range here, maybe you don't want to change the wire speed a whole number, maybe only half a number. Whereas if you're in the high range, changing it one number, you're really only going to change the speed about of 10 or 15% for each number on the dial. So keep that in mind, and now at least you know what the numbers mean in terms of inches per minute on the wire speed. Okay, before I get into the actual welding current measurements that I took, I want to talk a little bit about the basic power supply for the Lincoln. It's what they call a tap setting transformer, and I found this graph on the internet. It's for a Hobart Handler 175 MIG welder, so it's very similar to the Lincoln. It has tap settings on the transformer, and the tap settings, they identify them, Hobart, as ranges, range 1, 2, 3, 4. And on the Hobart, it'd be the range A, B, C, D, and E. So each time you change one setting, you're going to change the transformer output on average about 2 to 3 volts. And so the unique thing about this type of MIG welder is that you've got this slope where the voltage goes down, and that forces the transformer to put out a lot more current. So what makes this occur is when you have very low wire speeds, you got a lower frequency of arc shorts, and the arc gap is bigger, so the operating voltage on average is higher, which means the current is on the low end. When you dramatically increase the wire speed, you're getting much more frequent arc shorts. On average, the arc is shorter, which drops the voltage down, and that forces the welding current to go up rather dramatically. So it's this slope of this curve that really allows this transformer to give you the characteristics you need to do MIG welding. When you increase the wire speed, the current goes way up. So I didn't compare this to the Lincoln. I don't have this much data to draw these lines all out, but what I did do, I took some of the data that I had where I had 100 amperes of welding current, and I plotted it on this graph to see what the voltage was at 100 amperes for the different tap settings, A, B, C, D, E. And so here you see them superimposed on the Hobart graph. And I think if I had data out here, it'd be pretty similar slope to these. So it covers a pretty nearly the same range in voltage and current. So if I go down a little bit here, you see in the table, this is actually the open circuit voltage I got from the factory. That would be when you weren't drawing any current from the transformer at all. Of course, that's higher. And then these are the voltages I got at 100 amp current for some of the testing that I did. And this is sort of the range where I did the testing, the voltage for each one of these tap settings. And most of the testing I did was the 025 wire. And then finally I put some bigger wire in there, 035, to see what the maximum was this welder would put out. And you'll see that data in the next couple of slides that I have. Okay, here's the first graph I had where I was simultaneously measuring the arc voltage and the welding current. I ran each one for just a few seconds here, just long enough to get the data. This particular graph is data where I used the B voltage setting on the welder, 025 wire, and I was measuring 100 samples per second, welding on 1/8" steel. So the blue line here is the current in amperes, and the magenta line here is the voltage on this axis here. These little numbers here, 2, 3, 4, 5, 6, these are the wire speed settings. So this would be a very low wire speed. This would be a very high wire speed. And so you see, when you increase the wire speed, the welding current goes up rather dramatically, and the voltage creeps down just a little bit. So this is, of course, the way these things are designed to operate. A couple things noted here. This is below the wire speed recommended by Lincoln for any typical weld settings, and this would be above the recommended settings for this size wire. So here the wire is just sort of spitting and sputtering. It's not really coming out fast enough to make a decent looking weld at this B setting. Here the wire is coming out very fast, over 400 inches per minute, and that's coming out so fast that I could actually feel the wire poking into the pool when I was doing the weld. But actually the weld still looked pretty good even at this very high wire speed. Okay, here's the welds from that graph that I just showed you at the different speeds, 3, 4, 5, 6, 7, 8, 9. And surprisingly, all the welds, look pretty decent. And there's not that much difference in the wire speeds. But of course, at higher wire speed, I was certainly increasing the travel speed of the torch, a lot faster to keep up with the wire feed. So that's why the welds don't really look too much bigger, even though there's certainly a lot more amperage in weld number 9 than there was 3. I'm just traveling a lot faster with the torch. Okay, this graph shows some more testing that I did, except in this case, I actually had 2 electrical amplifier circuits that were measuring the current off of the 300 amp shunt. One was just a simple op amp 741 circuit that I built, and then this one is a commercial instrument amplifier. So both of these were hooked up to the same shunt, and they're both measuring current at the same time, well, I was also measuring the arc voltage. And so you see that these are plotted as two different color lines here. And you can see that the welding current from both circuits that I had, it's virtually identical measurements of the welding current. So that should be really a pretty precise number. And here is the arc voltage. So like we saw in the previous graph where I had the B voltage setting here, now I've stepped it up to the C voltage. Same 025 wire, same 100 samples per second. And I started at a higher welding speed because I just needed to faster wire speed at this setting. So I started at a wire speed of 4, went all the way up to 10. And again, you see as you increase the wire speed, the welding current goes up dramatically, and the arc voltage creeps down just a little bit at a time. So we're about as much current as we can carry through a 025 wire, and this speed is a little bit too high. Again, the wire is poking into the pool, and that's why you see these big excursions in current and voltage. The wire is just banging into the pool. But again, out here the welds still look pretty good, even up here at this higher weld speed. Okay, and here's the welds using the 035 solid wire at the highest voltage E setting. So you see 4, 5, 6, 7, 8, 9, and you can see there's more spatter in the 8 and 9, especially because the wire is really poking into that pool. It's coming out so fast. But of course, you got to move pretty fast when you get up to that high of a current level. Okay, my last graph here, I decided to crank up the machine and send it up to the max, see what kind of current it puts out using bigger wire, 035 solid wire, the same two circuits measuring the welding current. And I don't have the voltage line plotted down here, but I put the numbers, the average arc voltage down here just so you can see what it is. And these are the different wire speeds, 5, 6, 7 through 10. And this happens to be the actual inches per minute on the wire. So as before, you see as you increase the wire speed, the welding current goes up. And when we get up to about 400 inches per minute, you see we're right at the maximum 180 amps of the machine. So we're basically got the pedal to the metal here. This is all the welder is going to put out. And at the highest wire speed, 10, we see a lot of big variations in the welding current. Again, the wire is coming out of there so fast that it's just poking into the metal, and you can feel it through the torch. So it's just a little bit too fast for the amount of current that this welder can put out. So anyway, that completes all the testing that I've done on the machine. So if you have any questions or you want to add some of your recollections with the same machine or similar machine, feel free to send me some email. Hopefully this is all useful to you. Thanks for watching.